This video series goes through the daily problems in this maths calendar that is published by the American Mathematical Society. You can either purchase it through their website or via Amazon. Today's question is to find the slope of the line tangent to the curve y equals 2 to the power of x at x equals 4.6. Graphically, we have the graph of y equals 2x here. When x equals 4.6, we get this point here on the curve y equals 2x, and we want to know the slope of the tangent here. In other words, we want to know the derivative of y equals 2 to the power x at the point x equals 4.6. By definition, we look at a point very close to x equals 4.6 on the graph, and we compare how the function has changed between when x equals 4.6 and when x equals 4.6 plus a small amount. The increase in height of the function is given by the value of the function at the new point when x equals 4.6 plus h, minus the height of the function at x equals 4.6, namely 2 to the power 4.6. So the numerator here is how much the function has increased when moving from x equals 4.6 to x equals 4.6 plus h. When x moves from 4.6 to 4.6 plus h, the increase in x is just h, which is the denominator. This ratio then is thus the rise over the run. If this is our point on the graph here, when x increases by h, y increases by this amount here. So the rise over the run is this divided by this, in other words, this. And as we take smaller and smaller increments, we hope that the gradient converges to a limit, and that limit is the derivative of the function y equals 2x at that point, which is the same as the slope of the tangent line. We can try to solve this problem numerically simply by taking smaller and smaller values of h and evaluating the expression we found for the approximate gradient. This is known as a finite difference approximation. If we could compute to arbitrary precision, then this method would work well. The problem is that whether you use a calculator or a computer, it generally only stores a finite number of digits after the decimal point. And what happens when h gets too small is that you run out of decimal digits and you start getting nonsensical answers. For this particular problem, we compute the finite difference approximation, first when h is 0.1 to get 17.4061, then when h is 0.01 to get 16.8682, then h is 0.0001 to get 16.8105, then when h is 10 to the minus 6 we get 16.8100, and this is all looking very nice. The number is steadily decreasing, which tangentially is consistent with the fact that our function is convex. And the numbers are getting closer and closer together, suggesting that it's converging to a limit. So if we had to guess, we'd guess that the true answer is around 16.81. We can find an analytic expression for the answer by using the following trick. If we have one number to the power of another number, then the number b can be written as the exponential of the natural logarithm of b, because exponential and logarithm cancel each other out, so e to the log b is just b. And if we have got the exponential of something all to the power of a, that's the same as just e to the a times whatever's up here. So therefore b to the power a is the same as e to the a logarithm of b. Our function y equals 2x can therefore be written as y equals e to the x times the natural logarithm of 2. We know how to differentiate e to the alpha x. We get alpha e to the alpha x. Indeed, the derivative of e to the x is just e to the x. In some ways, that's its defining property. Its derivative is just the function itself. In our particular case, alpha is the natural logarithm of 2. Therefore, dy on dx is just the natural logarithm of 2 e to the x times the natural logarithm of 2. And e to the x natural logarithm of 2, just reversing this first step, is the same as 2 to the x. Therefore, the derivative is the natural logarithm of 2 multiplied by 2 to the power of x. Substituting in x equals 4.6 and using a calculator gives us that the gradient is 16.8098. This is very close to our numerical guess of 16.81. Technically, the calendar wants us to round off the answer, so the rounded off answer would be 17.